Assalamu alaikum everyone. So today we're going to start a new subchapter from chapter 12, which is the 12.4, the general curvilinear motion. Okay, so here in this chapter we're going to analyze the motion of a particle along a curve. So here, as you can see, this is basically a curve. Okay, along this curve there is a particle. To determine this position of this particle, we have to take a reference point, a fixed point. Here, in our case, the fixed point is basically the O. So with respect to O, the position of this particle is given by this vector R. So R is going to be called the position vector. Okay, and the distance that the particle travels along this path, that is defined by this S. S is basically the arc length. Okay, so here, as you can see, as this position vector moves, as the particle moves along this curvilinear path, so is this position vector, the direction and the magnitude, both of them are changing. If I want to show you, like, this is basically the position vector at this particular position, and if I want to consider another position of the particle, and you see, this is, let's say, R1, this is R2. See the direction of this R2 and the magnitude of this R2, both are changing. Okay, so as this particle moves along this path, both the direction and the magnitude, these two things change. Okay, so we can determine the position of a particle by this position vector. Okay, that is actually the position. Now we come to the displacement. What is a displacement? Displacement is basically the change of the position. So as you can see, at a particular time point, the particle along this curve at this point, and after a certain time period, the particle moves along this point. Okay, so as you can see, the first point from here to here is given by the vector R, and from the second point where the particle reaches to this point, then this vector is actually given by R prime. Okay, and then this vector will be called what? Del R. Basically, del R is basically the displacement, the change of the position vector, basically. Okay, so if I want to apply the vector rule, you can see one is this direction, another one is this direction, and another one is this direction. So this is R, this is del R, and this is R prime. So if I want to apply the vector rule, how can I write? It can be written as, sorry, it is R1, sorry, R. So it can be written as this and this are on the same direction, but this is on the opposite direction. So I can write R plus del R is equal to R prime. Clear? So that is, and from here you can determine the position vector del R as R prime minus R, which is basically the position vector. Okay, sorry, which is basically the change in the position vector, which is basically the displacement. Okay, now let's come to the next thing, which is the velocity. Velocity is what? The change of displacement with respect to time. So if I want to determine the V, so I can write the change of displacement, V average, with respect to time. Okay, and as you can see, there are two kinds of velocity. One is the average velocity, and another one is the instantaneous velocity. That can be when the del t approaches to 0. Okay, then del r by del t, and it can be further written as dr by dt. That is the v instantaneous center. Sorry, that is basically v instantaneous velocity. Okay, now there is another thing that is called the speed. Okay, so to understand the speed, okay, to understand the speed, we have to look on this curve. Okay, so as you can see, this length is determined by del r. Okay, and if I want to show you this curve, another, if I take another color palette, so if I draw the line, the arc length along this curve, that is basically del s. Okay, so basically this how it looks like. Okay, that will be your del r, and here along this will be, this curve length should be del s. Okay, so their relationship. So how did you determine the velocity, the average velocity and the instantaneous velocity? We have taken the time derivative of del r by del t, or dr by dt. That is basically the velocity. Okay, now what can be the speed? So by the definition, they're saying what is the speed? The magnitude of velocity. That is basically the speed. So here, as you can see, if for a small del t, okay, for a small del, if del t approaches to 0, then this del r is also approaches to del s. Okay, so we can approximate that when the time interval is very small, then this displacement vector approaches to the arc length, almost arc length del s. Okay, so del s is what? A scalar. Okay, so I can write del s by del t. Okay, and if del t approaches to 0, this can be written as ds by dt, which is basically the speed. Okay, so to get it, like if this, for a very small interval of time, this del r will be approaching to the very alike this curve. Okay, so if the time interval is very small, then this del r will be almost approaching to this arc length or arc displacement. You can say that the change of arc length. Okay, del s, the arc length del s. Okay, so I can write, instead of del r, I can write del s by del t, and if I take the del t approaches to 0, then ds by dt, and that is basically the speed. So v speed can be written as ds by dt, but velocity should be written as, okay, velocity, that is basically the vector, the instantaneous velocity, dr by dt. So here, what? The change of displacement, basically, okay, the change of position, dr. This is what? The change of arc length. Okay, change of arc length. That is basically your arc length. Okay, that the article approaches along the curve. Okay, so that is basically our discussion on the position, velocity and displacement. Okay, now let's move forward to our next topic, which is basically the acceleration. Okay, one more thing I forgot to tell, which is basically the direction of the velocity. Okay, if you draw a curve, okay, and the position of the vector is like this, and you have to know that the direction of the velocity should be tangent to this curve always. So that should be the direction of the velocity, always tangent to the curve. If the particle is here, it should be tangent to the curve. Okay, that's the direction of the velocity, always tangent to the arc length. Okay, that means the curve. Now, what is acceleration? Acceleration is basically, there will be two kinds of acceleration. One is average acceleration, and another one is the instantaneous acceleration. So the average acceleration should be the change of velocity with respect to time, and if the del t approaches to 0, it can be written as instantaneous acceleration, and which will be dv by dt. Okay, now what should be the direction of the acceleration? Okay, and how can we actually represent that in terms of like the change of velocity. Okay, because you see here we have shown, we have taken two positions, one was r and one was r prime. The change of position, that is basically with respect to time, which is basically the velocity. And here we need to show how the change of velocity will look like. Okay, so if I take at a time interval, let's say at a time interval t, the velocity is v, and after a certain time, let's say t prime, the velocity should be v prime. Okay, and that is basically the change of the velocity. Okay, and here these 2 points of this vector will coincide at this particular point. We can, let's say we name it O prime. So if you take any vector, okay, the initial point of any vector, this point where from where the vector starts, this is called the tail. Okay, and where it ends is called the head. Okay, so you see the tail of these two vectors v and v prime are fixed at O prime. Okay, fixed at O prime. And if you join, okay, sorry, if you join the heads, if you join the heads of these vectors, like the v and v prime, they will form a graph. Along the heads of this velocity vector, they will form a curve. Okay, and this curve will be called the hodograph. Okay, this curve will be called the hodograph. And what is the necessity of this curve? That basically tells you the direction of the acceleration. As you can see, we have told you the direction of the velocity is tangent to the curve, the position curve, or the S curve. Okay, but in here, how can you represent the direction of the acceleration? Okay, so if I take another color, so this is the hodograph, the black one. So the velocity, the change of velocity, that means the acceleration, should be tangent to this hodograph. So like this, the direction of acceleration. Okay, the direction of the acceleration. So how can we define the hodograph? That is basically the locus of the points of the velocity vector, I mean head of the velocity vector. Okay, the locus, what is the locus? Basically the points. Okay, so you can say that the locus of the points of the velocity vector, the head of the velocity vector, if you join the locus points of the head of the velocity vectors, then they will form a curve, and this curve will be called the hodograph. And what is the necessity of this curve? Basically it determines you the direction of the acceleration, the change of velocity. So if you take the tangent along this curve, this is basically the direction of the hodograph. So remember that the acceleration, which is tangent to the hodograph, not the S graph. Okay, not to the path of the motion. Okay, this is the velocity vector is tangent to the path of the motion. This is the path of the motion, but the acceleration is not tangent to the path of the motion. Rather, it is tangent to the hodograph, and hodograph is basically what? Locus of the head of the vectors. Okay, the velocity vectors. Okay, that's it. And as you can see, what is the path of the motion? You see, I can also determine the path of the motion. So if I take another color, so remember that was your fixed point, and from here the tail and the head should be where? This is, let's say, the position vector, the r, and here the another position vector, r prime. You see, this is the tail are fixed at particular point, the head are touching to a locus of this curve. So if you joined these locus points, that will form a curve. That is the path of the motion. So you can also say that locus of the points of the position vector form the path of the motion, but the locus of the head of the velocity vector, the points actually, they actually form what? The hodograph. But for the position vector, they form the path of the motion, okay, the S curve. So that is actually in case of the hodograph. But if I want to know the direction of the acceleration in terms of with respect to the path of the motion, so how can I say that? So you know that if I want to show here, let's say the previous space here, so this is a curvilinear path, okay. So this path is curved. To remain this particle along this path, this is a concave shape, okay. The acceleration should have to work inside so that they form this curve, concave shape. So in any curve, okay, the acceleration should work inside so that they form this curve or concave shape, okay. So that is basically the direction of the acceleration with respect to the path of the motion. But if I want to determine the direction of the acceleration with respect to the hodograph, that would be the tangent to the hodograph, okay. I think it's clear. Okay, now we move to the next topic, which is basically the curvilinear motion in the rectangular components. So basically you see this is the particle and this is the curvilinear path, and there are three coordinate systems. One is x, y, and z axis. So if there is x, y, and z axis, we can determine the position in respect to x, y, z axis, which is basically r, the position vector. This is basically the position vector r, which can be determined by x I cap, I is the unit vector in the x direction, plus y j cap, the unit vector in the j direction, sorry, the y direction, plus z k cap, the unit vector in the z direction, okay. So that is how can you define the position. So what should be the velocity? And the velocity should be dr by dt. That is basically instantaneous velocity. So if you take the time derivative of it, so that will be your velocity. So remember, there are basically two functions. One is x, one is I. So if you take the time derivative, you have to apply the UV rule of the differentiation, the two functions. So if I take the first function, derivation of the second, plus the second function, derivative of the differentiation of the first function, okay. So you see this is what I can write that v, this is dx by dt, this can be written as vx I cap, which is the velocity in the x direction. But what about this one, di by dt? Di by dt was the change of this unit vector with respect to time. But as you can see, and as our the x, y, and z reference are fixed, okay, this reference are fixed, so that the change of this unit vector di by dt or dj by dt and dk cap by dt will not change. So all of them should be 0. So this becomes 0. So you only end up with this one, so which is basically vx I cap. And if you in the same way do the differentiation of this one, you're gonna get vy j cap and vz k cap, which is basically the v, the velocity, the instantaneous velocity, okay. And another thing that it can vx can be written as also x bar, x prime, actually x dot. This is called the x dot. X dot basically represents dx by dt. Dot represents, remember always, time derivative, okay. If there is any dot in any function or anywhere, you have to remind yourself that this is a time derivative, okay, with respect to the time. So that is basically the velocity and position. Now if I go to the next slide, okay, there is also acceleration, okay. If I want to show you on this page, so our v was vx I cap plus vy j cap plus vz k cap. And what should be the magnitude of this vector? So v, the magnitude would be, you know that, vx square plus vy square plus vz square. Okay, and what should be then acceleration? Similarly, acceleration would be ax I cap plus ay j cap plus az k cap. Okay, so what should be the magnitude of the acceleration? It can be written as ax square plus ay square plus az square. Okay, that should be the magnitude. So that is basically the theory for this subchapter 12.4, the curvilinear motion. Now we're going to solve the maths. Okay, so we're going to start with the example 12.9. As you can see, at an instant, the horizontal position of the weather balloon in this figure is given as a function of x. Okay, so x is a function of 8t. Okay, and you are asked, and then if the equation of the path of this motion, the path of the motion is what? Y is equal to x squared by 10. So if these are given, you are asked to determine the magnitude and the direction of the velocity and the acceleration at t is equal to 2 seconds. Okay, so first of all, what you need to do, we are given x, so I can write the vx should be what, or x prime, or vx, that can be written as dx by dt. Our x is this one, d by dt, 8t, so that would be what, only 8. So 8 meter per second, that is our velocity in the x direction. Now what we need to do, we need to find the velocity vy, that is basically the dy by dt. But you see, to do that derivative, you have to follow the chain rule of the differentiation. Okay, so remember, here y is a function of x, y is equal to x squared, so y is a function of x, and you see x is a function of t. And if I want to follow, what we need to find, what, dy by dt. So if I want to find the dy by dt, I have to go from dy by dx and dx by dt. Okay, so I can write that dy by dt instead of dy dx and dx dt. That is basically the chain rule of the differentiation. So what should be the d by dx? Y is x squared by 10, and dx by dt is basically what, x dot, that is the time derivative, that means the vx. So it should be 2x by 10 x dot, I can write that x dot 5, that is basically the vy. So at t is equal to 2 seconds, vy should be, x value is what, x value is, you see, 16 feet is given, so x value is 16, and our x dot is 8, and here 5, so it will end up with 25.6 feet per second. And what should be the direction? It would be in the upward direction, because upward is positive and we have got the positive value. So what should be your v? V should be root over v square plus vy square, and that will end up with 26.82 feet per second. Okay, and what should be the direction of it? The direction can be determined by tan theta would be what, vy by vx. So if you take theta from here, you're going to end up with 72.6 degree. Okay, now the velocity is done. Okay, now we are asked to determine what, the acceleration. Okay, so we're gonna find the acceleration. Okay, so what should be the v? We have x dot vx as 8, so what should be x double dot? it should be ax, it should be 0, because if we take the time derivative of a constant, it will be 0. So x double dot ax is 0. And what should be your ay? Ay would be time derivative of vy. So our vy is x dot divided by 5. So these are two functions. You have to differentiate considering this x and x dot as two functions. Okay, so first of all, the first function x by 5 and derivative of the second x dot by dt, and then the second function and differentiation of the first dx by dt. Okay, so it will be what is this? Time derivative of velocity. It will be acceleration, x double dot plus x by 5, and this is also what? This is also x dot, the time derivative of position, that is the velocity in the x direction. So from here we have to find the ay. So x value is what? Sorry, x double dot value is what? X double dot value, if you see here, x double dot value is 0. So this term becomes 0. So we just have to work with this one, x dot square by 5. What is x dot? X dot is 8. So it should be 8 square divided by 5. And you will end up with 12.8 feet per second square. Okay, and as a as ax is 0 and ax is 0, then a should be also is equal to ay, which is basically 12.8 feet per second square. Okay, now what should be the direction of it? So the direction would be tan theta would be ay divided by ax. So 12.8 divided by 0. So if something divided by 0, it should be what? If tan infinity, tan undefined, actually 1 by 0 is infinite, tan undefined is basically theta is equal to 90 degree. Okay, so we have theta v and this is theta a. So this is the direction of the velocity and this is the direction of the acceleration. So how will it look like? So this is your balloon. So what should be the direction of the velocity? Tangent to the path of the motion. This is the path of the motion, the blue one. So tangent, okay, that will be your v. Okay, and if you draw a horizontal line, that is your theta b. And what should be the direction of the acceleration? It should be inside this path of the motion. Okay, and 90 degree along this horizontal line. So it should be like this. So if I use another color, so this one is basically theta a. Okay, so this is how you need to solve this problem. Okay, now we'll move forward to the next problem. Okay, so this is the next example, 12.10. So if I read the question, so for a short time, the path of the plane in figure 12.19a is described by a function y. Okay, this is the function y of x, and if the plane is rising with a constant upward velocity 10 meters per second. So upward velocity is given, that means vy is given as 10 meters per second. And we have to find the velocity and the acceleration at y is equal to 100 meter. Okay, and we have given an equation of y. Okay, y is what? 0.001 x square. So for y is equal to 100, what should be the value of x? So if I put y is equal to 100, then what should be the value of x? So x value will end up with 316.22 meter. So when y is 100 meter, the x should be 316 meter. So it's not millimeter, it should be meter. Okay, So now you have to find the velocities in a similar way, Here you see y. Y is a function of x and x is a function of t. So y is a function of x and x is a function of t. We have to find what? Dy dt. So we have to come from dy by dx and here dx by dt. So I can write v so I can write vy vy should be what? Dy by dy by dt. Okay, so what is dy by dt? I can write dy by dx and dx by dt. What is dy by dx? If I do the differentiation, 0.001 x square and dx by dt is x dot. So if you do the differentiation, you're going to end up with 2 into 10 to the power minus 3 into x, and there is x prime, which is basically what? Vx and vy. We have what? We have vy value. This should be what? 10. Okay, and x value should be what? 316.22, and we have to find the value of vx. So if you find the value of vx, you're going to end up with vx as 15.81 meter per second. Okay, and then the total v should be what? Root over vx square plus vy square. It should be 18.71 meter per second. And what should be the theta v? It should be tan inverse vy by vx. So if you do this calculation, you're going to end up with vy by vx as 57.69 degree. Okay, so our velocity term is done. Now we have to find the acceleration. Okay, so how can I find acceleration? Similarly, okay, ay should be what? D by dt vy. So vy is 10, so it should be 0. So remember, that means ay is 0. So what should be ax? Ax should be d by dt vx. So if I go here and if I make an equation of vx, vx is v okay, I do not need to do that. Okay, we're gonna find the ax in a different way. Okay, so we are given what? Vy as 2 into 10 to the power minus 3 x vx. Okay, I'm just writing this equation. Okay, so if you take the time derivative on both sides, okay, so d vy by dt is what? Ay. Okay, and this is a constant 2 into 10 to the power minus 3, and you have to consider that as an easy rule. Okay, so the first function differentiation of the second plus the second function differentiation of the first, and the 2 into 10 to the power minus 3 is multiplied with the whole thing. So if you do the calculation, it should be what? This is what? X. This is x dot or vx. Let's write vx. No, this is not vx. This is basically ay. And this is basically ax. Sorry, in the x direction, and plus vx, and this is what? This is also vx. Okay. And what is ay? Ay value is 0. So this term is also could cancels out. X ax plus vx squared is equal to 0. So from here we need to find the value of ax. Ax should be minus vx squared divided by x. Okay. What should be the value of vx squared? From here, if you see, vx is given as 15.81. So 15.81, and x should be 316.22. So if you do the calculation, you're going to end up with 0 point negative 791. That should be the ax. Okay, and then what should be the value of the a should be actually also this one, because ay is 0, so ax and a should be same. But what should be the value of theta? If I show you the coordinate, this is x is negative minus 0.791 and 0. So if you consider the coordinate system, this is plus plus, this is minus plus, and this is minus minus, this is plus minus. So you see we have minus plus, so this is in second quadrant. So if this is in second quadrant, then what should be the value? Tan inverse minus 0.791 divided by 0. Okay, this should be the theta a. So as you can see, anything defined by 0 is supposed to be 90 degree, but you see that should be in the second quadrant, so 90 degree will be replaced by 180 degree. Okay, so this is how you need to do this math. Okay, so now we're going to start the new subchapter 12.6, the motion of the projectile. Okay, so I think you have idea about the projectile. That is also the motion along the motion of a particle along a curve. Okay, so that is also a projectile. Okay, so now in the projectile we'll be solving for two axes. One is the x-axis and another one is the y-axis. Okay, so this is the path of motion of the particle. Okay, so initially the particle is at this position. Okay, so the particle has two this is the particle velocity v naught. So it has two velocities. One is v naught y and another one is v naught x. So after some times the particle reaches at this particular point. So at this particular point you also have two motions. One is the vx and another one is the vy. Okay, and remember here the acceleration works in the y direction is negative g. So what should be the equations of the motions for the horizontal case and the vertical case? So the horizontal case, if I take on the right side as positive, so you see the first one is v is equal to v naught plus act. Okay, the normal equations, just you have to actually represent that in the x direction. So v is equal to v naught plus act. So v naught is what? V naught should be only the x direction will be considered. Okay, and ax, that means the acceleration in the x direction is 0. That's why ac becomes 0. It only becomes vx is equal to v naught x. Okay, now the second equation is x is equal to x naught plus v naught t plus half act square. So you see the act is 0. That means the acceleration of the x direction is 0. So that portion becomes 0. So only we have this equation. So x naught is the initial from here we're actually counting. This is a reference point. From here we're actually calculating everything. So from here where the particle was actually being thrown, so at this particular point, so the distance is defined at x naught, the vertical distance is defined by y naught. So that is basically the initial x naught and y naught. Okay, so v naught, this v naught should be only in the x direction. You see, this should be the v naught only in the x directions, v naught xt. What about this one? This one, you see, ac terms 0, so this terms becomes 0. So only we'll have v square and v naught x square. So vx, this is v is also vx, because we are also calculating that along the x-axis, because horizontal axis we have taken the horizontal axis, you see. So that is basically the vx. So you see in the x direction the v does not change, basically v naught x. In the x direction, the v does not change. Only in the y direction there will be changing of the velocity happening. So this is about the horizontal axis. And what about the vertical axis? In the vertical motion, you see this equation is the same. V is equal to v naught plus act, y is equal to y naught plus v naught t plus half act square, and v square is equal to v naught plus 2ac plus y minus y naught. Okay, so y minus y naught is what? This from here everything is calculated. This from here to this the final point of the particle is x. Okay, so this portion, okay, if I take a different color, this to this portion is what? X minus x naught. Okay, up to the point where like up to the x where the particle is actually in motion along this curvilinear path or in the air. Okay, so that is basically x minus x naught. So now if you see here we have AC is what I have written. AC is equal to negative g. Okay, so v naught should be what? In the y direction. Okay, we have to take, because we are taking the component in along the y axis, so this v naught should be in the y direction, v naught y minus gt. Okay, and then this equation should be what? Y is equal to y naught plus v naught yt minus half gt square. Okay, and this equations becomes v square vy, because we're taking the component along the y-axis. So this v is equal, so this will be v naught y square minus twice g y minus y naught. Okay, so this is how you need to do or represent the equations of motions along the horizontal axis and along the vertical axis. One more thing, what is basically the v naught y? So you see, if I take here, look at here, so that is basically the v naught. So we have one in the, this is the v naught x and this is the v naught y. So if this is the theta naught, okay, so v naught y should be v naught sine theta naught, and v naught x should be v naught cos theta naught. So that's basically these things. Okay, these things, and v naught x, these things, and these things. Okay, basically the cos component, cos and sine, the x component and the y component. So that's these are the equations that you will be needing to solve the problems in this chapter. So let's go to the problems one by one. So the first problem that we're dealing with is this example. Okay, so you see the exact slice of the ramp shown in the figure with a horizontal velocity v naught. That means this velocity is what? This velocity, if I take, the point is given as a, so va in the x direction is given as 12 meter per second. Do we have any va in the y direction? No, because it's just the motion is in the horizontal motion, so it should be 0. Okay, determine the time needed for the sack to strike the floor and the range r where the sacks begin to pile up. So this r you need to determine, and also the time needed. The vertical distance is given as 6 meter. So which equation you have to use? You have to use basically this equation. Okay, so if I go here, we have to find the the time needed to reach from A to B. Okay, so YB, okay, YB is equal to Y naught. That's basically the A plus VA in the Y direction, because we are taking the components along the Y axis, so everything should be along the Y axis. Okay, so V naught Y t minus half gt square. Okay, so from here, what do you know? Okay, remember one more thing. This is your reference point. Okay, this is the x-axis. If anything above the x-axis, that is positive. If anything below the x-axis, that is basically the negative. You know, this 6 is below the x-axis, so that's supposed to be negative. So yb is -6. So -6. Why not a? We do not have any initial anything. Okay, so that should be 0, and v naught vay is also 0. So we only have half gt square. So g value is what? This is in 9.8. Okay, it's 9.81. Okay, so if you take t, it will end up with 1.11 seconds. So that will take this sec to reach from point A to B. And you are now asked to determine the range or the distance, the horizontal distance r. So which equation you have to use? You have to use this equation. X is equal to x naught plus va xt. Okay, this equation. So we do not have any x naught, that should be 0. We have a va x, that is basically 12. So 12 times what is this? Should be TAV from A to B, that how much time it needs to reach. So it should be 1.11. And if you do the calculation, you're going to end up with this basically R x, and that's basically 13.28 meter. So that is your answer. Okay, this math is very easy. So now move forward to the next problem. So in this example, you see the chipping machine is designed to eject wood chip at an initial velocity v naught is equal to 25 feet per second, as shown in this figure. So this is your v naught. Okay, and this the initial theta naught is given as 30 degree. Okay, and the horizontal from horizontal, determine how high the h. This length you need to find, and the chip is strike the pile if at any instant they land on the pile of 20 feet from the tube. Okay, so this length is given as 20 feet. Okay, and from the ground to the x-axis, this length is given as 4 feet. Okay, so which equation you have to use? Okay, first of all, we are given the horizontal distance. We given the initial velocity, so we know the horizontal velocity as well, because and that should be the just cos theta naught. So, and we need to find the t. So which equation you have to use? We have to use x is equal to x naught plus v naught xt, this equation. So what do we know? We do not have any x naught, that should be 0. We know this x, this is 20 feet, and we know this one, this is what? V naught, that means 25 cos 30 degree, and we have to find this t. So what will be the value of t? If you do the calculation, you're going to end up with t as 0.923 seconds. Okay, so that is the time that will take this wood chip to reach this 20 feet horizontal distance. Okay, so one problem is done. Now what we're asked, we're asked to find the h. So how can you find this h? So we have to use the y equation. Okay, so y is equal to y naught minus plus v naught yt minus half gt square, this equation. So y is what? The distance, and as I said, this is your x-axis. If anything below x-axis, that should be negative. If anything above, that should be positive. So this h is above. So if you look at this particular thing, okay, this length, this amount of length, the total from the ground to the x-axis is 4 feet, and from the pile height is h. Okay, so what should be this length? This should be 4 minus h. Okay, so y should be 4 minus h. That is basically below the x-axis. So that should be your negative. Okay, we do not have any y naught. We have v naught. So v naught should be what? Initial velocity 25 sine 30 degree times the t is this one, 0.923 minus half into 9.8 into 0.923 square. Okay, now if you do the calculation and if you solve for this h, you're going to end up with h value as 1.82 feet. And do remember, use this negative sign. You know why? Because you see this is the length which is 4 minus h, and that is below the x-axis, so it's supposed to be negative. So that is actually the answer. Now the next problem. Okay, so in this problem, example 12:13, so the track for the racing event was designed so that the riders jump off the slope 30 degree. Okay, so this is the ramp, and the driver jump off at an angle 30 degree. So this is 30 degree, okay, at a velocity probably v naught or what. Let's read. And from the height 1 meter. So this, the x-axis height is, this height is 1 meter from the ground. Okay. During the race, it was observed that the rider shown in the figure 1223A remained in mid-air for 1.5 seconds. So from this point to this point, the time take is 1.5 seconds. Okay. Determine the speed at which he was traveling. That means you are asked to find the v naught. Okay. Before striking the ground, and the maximum heights he attains. Neglect the size of the bike and the rider. So which equation we have to use? We are given a vertical distance and the time. Okay, so you know that which equation we have to use, y. So we have to use y is equal to y naught plus v naught y minus half gt square. Okay, the initial theta naught is given as 30 degree. So y is what? Y is -1, because that is below the x-axis, and do not have y naught. And v naught y is v naught sine 30 degree, v naught t, so there should be t. Okay, times the time is what? 1.5 second. Okay, minus half into 9.81 into 1.5 square. So if you solve for, there's only one unknown. You see, only one unknown. If you solve for v naught, you're gonna end up with, if you solve for v naught, you're gonna end up with v naught as 13.38 meter per second. That is the initial velocity at which he is going to actually take off from here. Okay. So one problem is done, and then what you were asked, the maximum distance h. This is the distance h you're asked. Okay, so if I show you here, this is h. So if I take a different color, okay, so you know what should be, like this, from here to here, this distance is given sorry, not this distance, this is your ground, this is the ground. From here, this distance is given as what? H, and this distance is given as 1. So what should be this distance? This distance is h minus 1. Okay, and that is above the x-axis. This is your x-axis. Okay, that is above the x-axis. So which equation we have to use? Okay, before that, I think we can also determine the r with a very simple equation. So our equation should be x is equal to x naught plus v naught xt. This equation we have to use. We do not have any x naught, so x should be r. V naught, we have a value of v naught, 13.38 into cos 30 degree times 1.5. So our R should be 17.38 meter. Okay, now we have to find the value of this h. Okay, so if we calculate everything above this x-axis, so we can take this h minus 1 as positive. Okay, so which equation you have to use? We have to use, we have highest, the highest point. Okay, you ask the maximum height. At the maximum height, what should be the vy should be 0. Okay, at the maximum point. So we have vy square is equal to v, let's say initially we have v naught y square minus twice gh. Okay, that equation, twice g and s, the distance. The distance, if it is below, then it should be negative. It is above the x-axis, it should be positive. You know, we are taking only this length. Okay, if I take different color, we are only taking this length. So this length is above the x-axis, so h minus 1 is positive here. Okay, so h minus 1. So what should be v naught square? That should be 0. va square we know, 13.38 into sine 30 square minus 2 into 9.81 into h minus 1. Okay, there is only one unknown, this is h, and if you solve for h, you're going to get the value of h as 3.28 meter. So that is the highest or maximum height that this bike is going to achieve. So that is how you need to solve this problem. Okay, we'll solve one exercise for this subchapter. So that is the exercise 1286. Okay, so if you look at this exercise, this is a very interesting problem. So you are given a ball that he is going to kick, okay, at an initial velocity v naught and at initial angle theta naught, so that it can pass, okay, it can just cross over this 3 meter fence, and the horizontal distance that it travels is 6 meter. So you're asked to determine the minimum initial velocity v naught. You know, important word, keyword, that is basically the minimum. Okay, so how to proceed? We are given two values. One is 6, the horizontal, and the vertical 3. So x and y equation we have to use. So what is the x equation? X is equal to x naught plus v naught x. Okay, so how can I write that equation? X is basically what? 6. Do you have any x naught? We do not. So v naught should be what? We do not know v naught. We have to find the v naught. So it should be v naught cos. We do not also know the theta naught. We do not know the theta naught as well. So theta naught, and there should be a t. Okay, that is your first equation. So from here, if you write for, this is your first equation, if you solve for t, that should be 6 divided by v naught cos theta naught. This is equation number 1. Okay, now we know the vertical distance, that is the fence height, that is basically the 3. So if I solve for 3, so y is equal to y naught plus v naught y t minus gt, half gt squared. So what is the value of y? Y value is 3, y naught value is 0, v naught is v naught sine theta naught t minus 4.9 t squared. That is your equation number 2. If you input the value of t here, okay, then you're going to end up with 3 is equal to v naught sine theta naught times 6 divided by v naught cos theta naught minus 4.9, also t, you know, we have also t here, So it should be 6 divided by v naught cos theta naught half gt square. So that should be whole square. Okay. So if you do the calculation, this v naught cancels out. We have 6 sine theta naught divided by cos theta naught minus 4.9 times 6 square divided by v naught square cos square theta naught. Okay, if you took the LCM, so the LCM should be v naught square cos square theta naught. So cos theta naught should be 6 v naught sine theta naught cos theta naught minus 4.9 times 6 square. Okay, see, I can write the 6 as 3 into 2. Okay, so you see 2 sine theta naught cos theta naught, that should be what? 3 v naught sine 2 theta naught minus 4.9 times 6 square. Okay, and here we have v naught square cos square theta naught, that should be 3. So if I solve for 3 here should be what? Here should be v naught square, sorry. So now if I solve for it, like v naught square cos square theta naught, that should be 3 v naught square sine 2 theta naught minus 4.9 times 6 square. Okay, so now if I take the constant on one side, so and take 3 v naught square as common, so it will end up with 3 v naught square sine 2 theta naught minus cos square theta naught is equal to 4.9 times 6 square. Okay. If you do the further calculation and solve for v naught, then you're going to end up with v naught as root over, we have a square, okay, so there will be root over 58.8 and this value, okay, sine 2 theta naught minus cos square theta naught. Okay. What we are asked in the question, we're asked the minimum initial velocity. So if this should be minimum, then this denominator should be what? This denominator should be higher. The higher the denominator, the less the v naught. So we have to take the differentiation of this, okay, with respect to theta naught to find the maximum value. So d by d theta naught sine the 2 theta naught minus cos square theta naught, okay, and that differentiation with respect to theta naught, to make it maximum, it should be 0. Okay, because at any maximum, you know that if anything is maximum, the slope is 0. Okay, so that's why we're taking it to be 0. So what should be the differentiation of it? It should be sine is 2 cos 2 theta naught minus cos square differentiation should be what? 2 cos theta naught minus sine theta naught should be 0. So if you do the calculation, you're going to end up with tan 2 theta naught is equal to -2. Okay, so that's you need to understand. So if you do use your calculator, okay, if you do use your calculator and solve this, you're going to get the theta naught as -63.43. Okay. If you just solve it and do not use your intuition. So if I draw it here in this page, okay, that was your basically here the football was thrown at a velocity v naught and at an angle theta naught. So that was your curve, and that length was 3 and this was 6. Okay, so suppose you draw an axis here. Not here, basically the initial point and this point. Okay, so where is -63.43? That's basically on the fourth quadrant on this axis. That is basically -63.43. What should be the positive value of it? You have to add 180. Okay, if you want to, this is from negative x-axis. It is clockwise. So it is negative from the negative x-axis. Okay, clockwise direction. So if you take in the positive with respect to the x-axis, this is your x-axis. In anti-clockwise is positive. Anti-clockwise, this should be the angle. This should be the angle. Okay, then what should be this angle? This angle should be this -63.43 plus 180, and you're going to end up with, what does it come? -63.43 plus 180. It comes as 116.5 degree. Okay, so that will be your, will that be your angle? No, that cannot be your angle. Okay. No, sorry, I have made a mistake. Forget about it. Basically this is your now 63 point, if I take a different color. Okay, that is your negative angle that is calculated. It is negative, so it should be clockwise in the direction, and that should be counted as negative x-axis. Okay, so that is -63.43. that should be counted clockwise from the x-axis. Okay, now if you take if you calculate with respect to the positive y-axis, okay, then what will be its value? What will be its value? Its value should be this angle. Okay, this angle. So to find this angle, you have to add what? -60.43 plus 360. So you end up with for which angle? -63.43 plus 360. You're going to end up with 296. Okay, let me check. This is basically the value of 2 theta naught. Sorry, this is the value of 2 theta naught. 2 theta naught is this one. Okay, 2 theta naught is this one. So this is calculated from the negative x-axis. Okay, if you calculate from positive x-axis, that will be your angle, and if you calculate from the positive x-axis, you have to add 360. So this is 296 degree. Okay, so that is basically the 2 theta naught is 296 degree. So theta naught should be what? Plus 360 divided by 2, and it comes as 148.28 degree. Okay, so if I draw the angle here, 142.8 degrees, so it should be somewhere here, isn't it? That should be 148 degree. So did the footballer kick the ball in this direction, no, he did on this direction, that is the theta naught. Okay, so you cannot take this angle. Okay, you cannot take this angle. So what you need to do, as I said, is as I solved in the previously, you have to take the opposite angle of it. Okay, so what should be the angle on this direction? What should be this angle? Okay, this angle, not this angle, basically this angle. This angle should be what? We have this one, and the total angle, this one is 180 degree, so minus 63.43 plus 180 degree. You are going to end up with 116.5 degree. Okay, so this is 2 theta naught now. Okay, this is 2 theta naught, 116.5 degree. What should be theta naught? 116.5 divided by 2, it is 58.25 degree. So now if I go here, so is it, yeah, it can be 58.25. okay, because it's an acute angle. Okay, it is an acute angle, so it's less than 90 degree, it's not greater than 90 degree. So you see, if you solve for the calculator tan inverse 2, you're going to get the 2 theta naught as minus 63.43 degree. So that is basically minus 63.43 degree. And if you, this is calculated from the negative x-axis, and if you calculate it from the positive x-axis, this angle, so that becomes what? 296. So that is equal to 2 theta naught. And if you solve for theta naught, you're going to get the theta naught as 148.28 degree. So that is not possible. Why? Because this is greater than 90 degree, and he didn't kick the ball greater than 90 degree angle. Okay, so then what you need to do, you had this angle. Okay, you had this angle as minus 63.43. okay, you have to calculate this angle, this angle. So this angle should be what? The total should be what? 180 degree. So plus 180 degree, and then you're going to get this 116.5 degrees, and then that will be equal to 116.58, and if you solve for theta naught, you're going to get as 58.25. so this is an acute angle, less than 90 degree, so that is possible. So our theta naught should be 58.28 degree. Okay, and if you put this theta naught on this equation, then you can get the theta naught, because we have only theta naught here and theta naught here unknown. So if you put this theta naught on this equation, you're going to get the v naught as 9.75 meter per second. So the footballer needs to kick the ball at this velocity, at this angle, to reach 6 meter here horizontal distance and y meter fence. Okay, so that was a very interesting math, and you have to really interpret that angle. Okay, that how the things are happening. So that's up to it for this chapter. Thank you, everyone.